Hello. So the topic we would like to share with you is how we maintain the number of good URLs on Core Web Vitals above 99%. My name is Matsuura. I'm the front end team leader at Yahoo Japan. The service that I'm in charge of is called Yahoo Japan Job Catalogue. Yahoo Japan Job Catalogue is a service that supports job change and job hunting by providing information on employee reviews. And there are 4 items for today's introduction. What is a core web vitals, how to improve, and how to maintain high quality. Let me start by introduction. Now I'd like to ask you a question. Is SEO important for website? The answer is basically yes. Poor SEO will result in lower search ranking and you have fewer users. Fewer users means fewer sales, fewer number of restaurants, and troublesome. Another question, is UX important? Basically, the answer is also yes. When the users come to the page and experience, for example, the site display is slow or difficult to view or buttons hard to press, then the user will no longer use the site. And this will be a problem for us. So today's topic, the core web vitals affect SEO and UX. They're very important for anyone running a website. But many of the improvement measures for core web vitals are quite simple. I will introduce today some of the measures that have been particularly effective. Now about what are the core web vitals. Core Web Vitals consists of 3 UX metrics for loading web pages. From June 2021, Core Web Vitals became one of the SEO ranking factors. The 3 Core Web Vitals indicators are LCP, CLS, and FID. LCP stands for Largest Contentful Paint, and it's a time from the start of the page load to the maximum content visible. If that second is within 2.5 seconds, it's considered good. And of the 3 core web vitals metrics, it's said that this is the most impactful on SEO. In this example, on the left side is the start of the page load, and it is displayed as you go to the right. Green represents the maximum content. First, top left, then in the middle, text at the top in the middle, then finally the image is determined to be the largest content, then the time it takes for the image to appear is LCP. Another example of an LCP. First is a search window, then the next, the text at the bottom center, then image start to appear, but because the picture is smaller than the text, so the text at the bottom center is considered the largest content. CLS stands for Cumulative Layout Shift. It's a measure on how much a visual element is moved in the viewport. The more movement, the worse the score. Accordions, expansion, and other user-intended movements are fine as long as they are within 0.5 seconds, and CLS is also said to have a significant impact on UX. Next, FID. This stands for First Input Delay, and it's a time from the user action until the browser actually starts processing the event handler. And when I say user operation, I mean by form-based operations such as clicking links or pressing a button. Scrolls and zooming are excluded. As long as that's within 100 millisecond, that's considered good For example, have you ever experienced going to a website and immediately tap the button, but nothing happened? That means that the FID is long. And let us share Yahoo Job Catalogue status. You can get the status in the report user experience in the Google Search Console. In February 2021, the percent of good URL was about 30%, but it gradually improved. And now in April 2021, it became 98%. And at the moment, currently, for mobile, we have been maintaining above 99% for some time. And for desktop experience, we are at 100%. So how were we able to improve these values? And let me share some of the very effective countermeasures that we enacted on. First, to improve LCP. The key to improve LCP is how to display the maximum content as quickly as possible. And we must first know what that maximum content is. To identify the largest content, we can use Google Chrome's developer tools called Lighthouse. And you can run the analyze page load. Then a report gets generated, and the largest content for pane element of the diagnostic result. Then you can see where the largest content is loaded. The actual improvement includes browser loads HTML from the top. However, if there's a script tab in the middle, JS file download, parse, and execution, that happens, and it takes time to load that LCP element. To avoid that, on the script tag, add a differ or async attribute. Then you can then the script tab keeps it from stopping and load and start loading. Alternatively, you can move the script below the maximum content to load the LCP elements faster. If the largest content is an image, if there's more than one image, you never know which one gets downloaded first. But you can set the preload. Then you can specify the image to be downloaded before others. If the largest content is an image, you can set the image format to the WebP. Then the file size will decrease to about half or 1/6, which should speed up the download speed. And if you need to call the browser that does not support WebP, you can use a picture tag or image in next.js. And not only client size, but also the server-side improvements are quite effective to improve LCP. First, this is a simple system diagram for our service. Server size consists of BFF, API, and database. And the key to improving LCP on the server side is to reduce response time. With our service, BFF is able to respond within 400 milliseconds.
So this is how we implemented actual improvement BFF and API. We conduct a parallel operation. Then there should be the parallel operation. So in the node phase, after all the promises are implemented, you will await. However, if there are cases you cannot do parallel processing, in such cases, do not acquire the data at page load time. Instead, you use the intersection observer to acquire data when it is close to the display position. This speeds up the display page load time. And also, if there is a process that is slow, no matter how you do it, you can use a memory cache server such as Redis to store the response once received in the cache to speed up the response the second time and onward. In this diagram, the Redis is used for the API, but it can also be used for the BFF, depending on the situation. For database, in the case SQL is slow, then you can use the index, and also you should avoid the execution of the sum and average. So you prepare the data processing in advance. So improvements to the API and the database could be difficult for front-end engineers. So back-end engineers are also asked to help. Next, I'd like to talk about the improvement of CLS. The key points of the CLS are trying to keep elements as immobile as possible. For example, images and delayed data display, and advertising, and etc. First, here's how to improve the image. If the width and the height of the image are fixed, set the width and the height first. If the height varies with the width, prepare a div to ensure the height. For example, set the aspect ratio of the image to 1:5 and set the padding top in the div to secure the height, 20%. For the image tags set to position absolute and width, 100%, the height of the image will remain the same. Depending on which browser the service supports, you can also use the aspect ratio. This is simpler for implementation. In the case of the delayed acquisition of the data, heights vary greatly. And also the height cannot be accurately determined by the data. In that case, if the appropriate height is kept in a skeleton, the layout shift is virtually unaffected. For example, whose height is unknown for advertisement, you can preset the minimum height to reduce the effects of the CLS. Next, I'd like to talk about the improvement of FID. So there are reasons for why the input delay occurs. This figure documents browser loading of a typical web page. Gray is a request for a page, CSS, JS, web front, or image. Yellow is what the browser does after receiving the response. The processing is as follows: parsing HTML, CSS, and JavaScript, rendering to the browser, execution of the JavaScript. In the yellow state, the browser is busy and will not respond even if it accepts input. The reason why browsers tend to become busy is mainly because of the large JS file size. If you are using Webpack Bundle Analyzer is a way to analyze JS file size. It's easy to install. You can just change the installation and Webpack setting, run the compilation, and you can get the report. The Webpack Bundle Analyzer report is generated as shown in the image, with the JS with the largest file size starting from the top left. And press the latest part of the report, you can see more details. The larger the area, the larger the file size. And this report shows that moment, chart.js, and Lodash are the cause. So I'm trying to deal with the moment. In our service, we changed to plain JavaScript because we use it in only just a few places. However, if you needed to use it in many places or needed to support multiple languages, you can replace it with OSS such as Day.js, which has a smaller file size. Next is about Lodash. Lodash is a very useful OSS, but if you import everything, the file size tends to be very large. As a solution, we changed the import method because export is prepared for each function. Chart.js is an OSS drawing a graph, but we did not need to display the graph in the first view. So if we use the dynamic import, which can download JS when it is needed. Timing was determined by using intersection observer so that dynamic import would be running when the graph was approached. By doing so, we were able to reduce the size of the JS file for the first view. The specific implementation, on the left, we have a component that wraps chart.js, which is a heavy file size. On the right side of the file, we use the intersection observer to display the wrapped component when it is close. Thanks to dynamic import, it will download chart.js when it is displayed. These actions reduce the JS file size by 70% at the page load time. Meanwhile, if you are not using Webpack, refer to the Lighthouse diagnostic results. The URLs of JS that are causing load are displayed in the blue box. You can check for unnecessary JS by referring to it. So this is a common case of unneeded JS loading. From the top, unused JS. I used to use it until the middle of the purpose, but I removed the functionality no longer needed. So in that case, you will be just remove loading. Second, JS via tag manager. Tag manager can easily import tags for advertisement and access analysis. But there are cases where it is also used for unnecessary pages. Since the file size is often large, it's better to apply it only to necessary pages. Finally, use of unnecessary functions. For example, GA4's access analysis also changes the JS file size depending on the function you use. If you use the extended measurement function video engagement, even though you are not handling the video, it will affect FID, so you should check your settings. That's it for improvement. Next, I'd like to talk about how we have maintained high quality. First, we need to understand the current situation to know what the problem is. Google Search Console can be utilized. Google Search Console will tell you the status of your core web vitals. If there is a problem, it will show you a report and also tell you by email. So this will tell you if you need to take action first.
But there's an issue here. The data displayed in Search Console is a Chrome UX report, which is the data taken from the actual user's Chrome browser. So that means that the UX has already been affected. And one method of proactive detection is to use Lighthouse CI. Lighthouse CI is a tool that allows you to run Lighthouse automatically. Lighthouse CI can be integrated into the CI pipeline that you are already using. And this is an example of how CI can be incorporated. The first one, a developer implements and commits the code. And the second, run Lighthouse with a CI/CD tool such as Circle CI. And the third, a report of the execution result is generated in HTML, which is uploaded to the Lighthouse server and saved in MySQL. And the fourth, Lighthouse CI results, you need to verify the score for the execution result and it notifies you as an error if the score is below the threshold you set. And the developer can check the report on the Lighthouse server and take necessary action. So regarding a Lighthouse CI reports, the git commit hash is tied to the runtime report, so you can see which commit went bad. And when pressing report, you can see the details. And you can also compare the reports by clicking diff. These can save you time in finding the cause of the problem, and also you can fix the problem before the issue affects users. And regarding operation, if a website is run for a long time, then usually the talent resource become issue. Knowledgeable people may move on to another project. The newcomers may not be able to handle some difficult situation. And also, there are some time resource challenges. For example, when there are new feature development that requires a lot of resources, then you're not able to address to the core web vital improvement needs. So the solutions to improve core web vitals are quite simple, but you need to have a clear policy and how to respond, how to prioritize. For example, we are using for the tech, as an example, the expressed as a React, Next.js, and BFF. We are first be sure to use image of Next.js for image display, and the parallel processing with BFF, and delay acquisition of data that's slow to process. And also we use a skeleton display and dynamic import of heavy JS and the components that are not used. Depend on the condition, and also consult with the team when using JS with the large files. So this is a case of concrete example number 2 using movable type at CMS platform implemented with HTML and CSS. So implementation policy is as follows. In the case of LCP, use preload and WebP. And we guarantee this secure the image height. And for the image, we use loading equal lazy. And this is really not for core web vitals, but rather an implementation policy because it affects display performance. Now on to the summary. Core web vitals affect SEO and UX, especially LCP and CLS affect them. And use Google Search Console to understand the situation. LCP and CLS are relatively easy to improve, so there's no reason not to do them. And if you can maintain the implementation policy beforehand to avoid talent shortage problems and maintain the quality, and Lighthouse CI is very useful depending on the status of your project. That's all from me. Thank you very much. Thank you very much, Mr. Matsuura. From this point on, we will invite an interviewer for the Plus Talk section and dive deeper into the contents of the session. And we want to incorporate questions from the audience as much as possible as well. So if you have any questions, please feel free to submit your questions by clicking on the question mark button on the lower right corner of the screen. And the interviewer for this session is Mr. Hori from LINE. Mr. Hori, would you please briefly introduce yourself? Yes, I am Hori from LINE. I'm a front-end engineer. The product that I'm in charge is LINE News. Thank you very much. So, Mr. Hori, what are some of the points that caught your interest? Any questions to Mr. Matsuura? Thank you very much, Mr. Matsuura, for the great presentation. I myself, for LINE News, measuring performance metrics and I belong to a team whose responsibility is to improve the performance. So your presentation was very interesting for me. I have a few questions here. The first one is, let's say in preloads or there are some general, very common improvement measures. Once you've done the Lighthouse CI's lab environment, you check it, and as long as the results are good, you will deploy. Is that the way for you, the field is the Chrome UX report? Or you just release? Would you please share your process on deploying your countermeasures for improvement of core web vitals? For our team, Yahoo Japan, we are using Lighthouse from the beginning to regularly check on the core web vitals metrics. So we check it on Lighthouse Lab first. Then once we all know that it's impactful, has the benefits, then we release. So you can see that the effects were there, so that's already validated, then you released, or likelihood of making a positive impact. The use cases that we have introduced this time around, the countermeasures, we saw an improvement in the numbers in the Lighthouse. That's been confirmed, especially for preload. There was a significant difference, significant improvement. I see. What about WebP? For WebP, it really depends on the image sizes. For example, if the image size is larger the size, the bigger the impact. Makes sense? Yes? So it really depends on the original image file size. Correct. That makes sense. So you are able to use this tool in a really ideal way and to really generate the positive results. Yes, I think you can say that, but we have done some countermeasures, and some of the countermeasures did not generate the fruits that we have expected. For those cases we didn't share in this presentation. Yes, I had a similar experience too. So it's always a trial and error a bit.
Thank you very much. Next is about dynamic import. I have a question. Instead of asking you a specific question, I'd like to know about strategy or method. You refer to the chart. The chart is not loaded in the first UI, so there was the timing afterward, and the referee was improved. JS size, you paid attention to the JS size. But there is an example, the user-specific UI would exist, and so UI will be different from one user to another, or UI might get changed, and the chart will be incorporated in the top page or IAB test. You get a different UI. In those circumstances, how are you responding to that? Or you hadn't thought about it, or you try to optimize the current UI? Is that your focused approach? Yes. Please continue. Oh, excuse me, please. So in principle, yes, that's the approach we took. But naturally, in case of functional improvement, we continuously be working on it. So chart might be slightly incorporate in a, in those circumstances. If we will be just waiting for the dynamic import, that will be a more grave issue. Although it's a part of the dynamic issue, that it's a part of the first phase, so there was a partially impacted. That was the case we experienced. But we consulted with the designers about the challenge. Yes, that's the point I wanted to be very interested in. So you worked with the designer team or you worked with the business teams. Such coordination will be necessary, yes. But as our project, the core Web Vitals, regardless of the type of the profession, are well recognized by many. So it was easier to consultant on the topic. So it was easier for you to get their understanding and approval. So next question.
We are getting similar questions from the audience too. So let me read out some of them. When you have ads, advertisement, then that can impact performance, right? Yes, of course. And for line news, we post a lot of ads too, so that's a concern of ours. We are paying a lot of attention to the impact. So do you have any good countermeasures that you can recommend to us to not have much negative impact from having ads? Well, the kind of service that I'm in charge, we don't post too many ads, so that's not really a big concern for our team. Maybe a little bit, but I would think that Mr. Hori, your service probably you have more ads. Sometimes, some product that shows a big ad in the beginning. Well, most likely, I just would like to discuss with you whether there's something we can do or there's nothing we can do. How to approach that. JS for ads probably usually has a large file size, right? Yes. So, when I explained about the FID in the beginning, the reason why the FID gets delayed, I showed you with a graph in one of the page. Probably the browser JavaScript processing all at once then can get clogged up, can get too busy. If the ads.js can be delayed slightly so that the read time is not concurrent but a little delayed in reading it, maybe that would improve it. I think that's all I can think of. Yes, when we have a big ads, it impacts LCP as well as FID, probably.
I see. So I'd like to ask one more question if time allows me. Talking about the human resources. So you summarize the measures to how to deal with it, and I liked the information very much. So how did you decide to take on that? And is it based on your proposal, or team members propose and decide on that? For Core Web Vitals, I personally led the effort to deal with it. So basically, I summarized the measures for ourselves. I see. And I shared the measures with others and to implement them and to execute them. I see. The countermeasures had been identified, and then you can have a very productive time because you can utilize what's being discussed and be implemented very quickly. So even though there was a shortage or limitation of the resources, you found it easier to deal with it. Yes, in the development process, we clarify the direction to go, so everybody else will be in alignment with that direction. So we are in good alignment. I see. Thank you.
時間って
Yes, you have more time, so please feel free to continue with the question. Is that okay to read the questions from the audience too? Of course, yes, yes. Yes, that would be great to incorporate audience questions in this section. I do understand about the Google Ad situation. This is a question is coming from the same person. What about using Google Chrome Search Console? Are there any security concerns?
と複数
Because part by part, you have a React view mixed in with the website. Did you ever have any challenges in such a mixed page? First question is internal private page using a Google Search Console tool. Is there a security risk? Internal web page. I wonder. Maybe it's better to pick the other question about for the multiple. The development page developed by multiple teams. React View, mixed React View page. Is this, I wonder, for Is this question related to Matsuura-san's product, or is the question is about React? For me, we are doing React. So for Line, we are using React and Vue, both actually. For the top page, we're using React, so we don't have to think about using Vue, but. I see. I never really personally experienced a mixed page, React and Vue, so I don't know what the challenges that poses. In principle, when measuring core web vitals, usually one page, the first view, usually the top landing page, is what is a subject for this measurement. So even with a mixed page, only the main page will be the one that you are measured against. That's probably is sufficient in most cases. Can we move on to another questions? Using interactive contents, using Ajax. First of all, for a movie, we are not handling movies, so with the service that I'm developing. So that countermeasure, I wonder. I don't want to mislead the audience. So, well, for UI, whether you really need to have the large size file on top, my suggestion is to have a dialogue with the UI team, and if it's essential, then probably start to have some kind of a countermeasure for it. I wonder, having a poster image may be the way to go. That's just my first idea that came up to my mind. I mean, I'm not sure. We have to try. But another question?
操作 操作があってから。
So after operation of the user, there was a mistaken loading. So before user's operation, there will be no loading of the data. Oh, I see. So in that case, Core Web Vitals can be quicker. Yes, for Core Web Vitals, in principle, is related to the measure of the loading timing. So CLS with the user's operation in JAX, sometimes a shift can occur upon the user's operation. Yeah, you referred to CLS. That reminded me to have one more question about the CLS. You got the skeleton screen, but not partially. You are using a skeleton screen, not the whole. Yes, true. Yes, only for partially. I see. Not whole, not about the whole, but you use it just partially. What's the purpose for that choice? There was no need to apply it for the entire area? Yes, basically. Acquisition of the data, if you can have a parallel processing, the speed will not be slowing down significantly. But in some cases, the data acquisition may be slowing down only for that the situation skeleton will be utilized, and later there is acquisition data. So if we look at the core web UI, there is a skeleton for the entire portion. That's fine. But LCP, if it's behind the LCP, then LCP will be slowing down in those circumstances. Yes. So in order to speed up LCP, instead of dealing and hiding it in the web skeleton, only slow the portion should be hidden. For elsewhere, aspect ratio or the definition of the height will be the good measure to speed up LCP. I see. Only for the first view, then there should be no use of a skeleton. Is the way to go? For first view, amongst the first view, you will use it and apply it only at the bottom portion. I mean that the areas are not LCP related. I see. So the skeleton is not used for your LCP. No. I see. I understood. That's a great information.